Welcome you back. So in previous previous lecture, we have discussed about that we are using a radial basis function to make the non-linearly separable classes to a linearly separable classes, so that we can able to do the classification, and this can be achieved by a multi-layer neural network. So this whenever we are talking about more number of layers, this will give rise to deep learning structure. Or if you look into the introduction part of deep learning is nothing but a subfield of machine learning algorithms, and based on some set of algorithms that construct the models aiming to represent high level of abstractions. So this deep learning refers to deeply structured learning, hierarchical learning, deep feature learning, and the deep representational learning. Most common and popular DL structures, that is nothing but multi-layer models of inputs, that deep neural networks comprise of multiple levels of nonlinear operations. So if already we have discussed three things. One is called artificial intelligence, machine learning, deep learning, and the main component of this all kind of learning is nothing but the neural network. So if we'll look into here the diagram, this deep learning is a subset of this machine learning, and this machine learning is a subset of this artificial intelligence. So this deep learning emphasizes on the learning of successive layers of increasingly meaningful representations. What is deep in the sense? This deep represent in deep learning the successive layers of representations or multitude layers through which the data can be transferred. Or we can say that this deep learning is nothing but a layer representation or hierarchical representations. So in deep learning and are learned via models, that is the help of neural networks. So this deep learning is bio-inspired. That is the brains have a deep architecture, and the computers can emulate such deep architectures. Brain organize their concepts in a hierarchical fashion, that is learning of simpler concepts, and then combine them to represent more abstract ideas. This motivated the researchers to have many levels of abstractions and processing to solve the computational problems. So the classification of a deep architecture based on these three things. One is called the generative architecture, discriminative architecture, as well as the hybrid architecture. So what do we mean by generative architecture? This aims to characterize the high order correlation of properties of the input data for synthesis purposes. Discriminative architecture, it is used for pattern classification or recognition purposes. Hybrid, that is combines the both the generative and as well as the discriminative deep architectures. It carried out the discrimination task, which are aided by the optimized outputs obtained from the generative architectures. So if we'll look into this deep learning models, there are numerous or numerous models have been developed by the different researchers for multiple works or multiple purposes. So few of them have been represented here. LeNet, which is developed by Lee Kun and their co-researchers in 1998. This convolutional neural network, which is popularly known as CNN or ConvNet, that is developed by Lee Kun in 1999. Region-based CNN that was developed in 2015. Faster RCNN developed in 2015. You only look once, that is popularly known as Yellow Network. It is Redmond in 2016. ResNet, He et al. Developed in the year 2016. Region-based fully convolutional neural network, that is RFCN, developed in 2016. Neural architecture SourceNet, that is NASNet, was developed in 2016. Single shot multi-box detector, that is popularly known as SST, developed in 2016. Mask region-based CNN, that is known as Mask RCNN, developed by He et al. In 2017. DenseNet, that was developed in 2017, RetinaNet developed in 2017, and EfficientNet Tan and Lee in 2019. So these are many kind of deep learning models that have been used for different type of applications. But if we will categorize these deep learning models, they mainly classified into these 5 categories. Here I have summarized the 5 different categories of these deep learning models. That is convolutional neural network, which is popularly known as CNN or ConvNet; recurrent neural network, which is popularly known as RNN, or that is also long short-term memory network. If we look into this convolutional neural network as well as recurrent neural network, this convolutional neural network don't have the memory, whereas the recurrent neural network, or popularly known as LSTMs, which has the memory, stacked autoencoders, deep Boltzmann machines, as well as deep reinforcement learning. So we'll just look into this different type of models. The first model, that is nothing but CNN, that is convolutional neural network. So this is a discriminative deep architecture, which is similar to that of the artificial neural network. So both the architecture contains the neurons having learnable, that is known as the tunable weights or bias. Input is a vector for both the cases. ANN suffers from burden of dimensionality when the input is very, very large. So CNN deals the complex input. So CNN, that is convolutional neural network, has several Am I audible?
Yes, sir. Audible, sir.
Yeah. Okay. Thank you. My screen is visible to all of you?
Yes, sir.
Okay. So the slide is visible?
Slides are not visible.
Yeah. Now it is visible?
Yes, sir. Visible, sir.
Yeah. Thank you. So sorry for the inconvenience due to some network problem. This connection was disrupted. So we are talking about deep learning models, that is the CNNs. And in case of convolutional neural network, that lowers the values of its filters in a training phase automatically based on certain given task, generally trained by supervised learning, but can be used with unsupervised methods. So when we are talking about this CNN for the particular class of classifying the images, and we are talking about this deep neural network, it has many number of layers. That means the first layer, second layer, final, or maybe some hidden layers as well as the final layers. So what these different layers are used for, as already we have discussed in case of multi-layer neural network, as we are going increasing the layer, we are introducing the non-linearity. That means more non-linearly separable classes can be separated by a linear or can be represented by a linear separable class. So if we look into the first layer, that may learn to detect the edges from the raw pixels. The second layer can able to employ the edges to detect the simple shapes. And subsequently, higher layers use these shapes to learn higher level features like facial shapes and so forth. And final layer can classify or used for exploit the high level features. So as we are talking about the classification of images and we are talking about different layers, and if we go on more and more number of layers, the higher and higher level of layers, more and more complex features can be extracted out. So the layer which is very close to the input can able to extract the edges or the raw features. The layer which are very far away from the input can able to extract the complex features. So that means we are making a non-linearly separable classes to a linearly separable classes. Here one example I have given the models that is a shallow ANN architecture as well as a ANN architecture. If you look into the shallow ANN architecture, it has a input layer, hidden layer, maybe one more hidden layer is there, output layer. So this is a very shallow. That means the number of layers are very less in number. And if you look into the deep neural network architecture or deep ANN architecture, it has a many number of hidden layers. That is input layer, hidden layers, as well as output layers. So this is a deep learning model that is used for image classification. We will talk about more detail about this model. So there is an input, we are performing the convolution by the help of a kernel or a mask. Then we are performing the work of pooling operations. Then again, we can perform repeated convolution to extract the features. And again pooling, and we can may perform the convolution multiple number of times, multiple number of pooling operations, fully connected as well as fully connected, and we can get the output predictions. So here there is the CNN architecture for this digit recognitions, and the input is in this digit or the raw digit, and the final output to which class it basically belongs to. So this deep learning models is represented as convolution, ReLU, pooling, convolution, ReLU, pooling, convolution, ReLU, pooling, and this is the final layer, that is a fully connected layer. And then the last layer we can able to classify which class it basically belongs to. The next category of a deep learning model, that is known as the recurrent neural network, or that is popularly known as long short-term memory networks. So what is this long short-term memory network? If we look into this recurrent neural network architecture, it has an input layer, a hidden layer, another is the output layer. And if we look into this structure, there is a feedback from the output to the hidden layer, or maybe there is a feedback or there is a loop in the same layer itself. So that means there is a memory is associated with it. So in case of long short-term memory network considered to be a deep generative architecture, and the depth is very large to that of the input data sequence, and basically this is used in case of speech or text data, or in case of ECG analysis, that is electrocardiogram analysis to find the arrhythmia or the different conditions of the heart. And this type of network is not very popular due to the vanishing gradient problems. Already we have discussed that in order to make the predicted value is equal to the output value, basically this prediction depends upon the weights. And if the weight are generated or weights are calculated by calculating the gradient, and if the gradient vanishes, we cannot able to calculate the weights. So this type of neural networks, that is recurrent neural network or long short-term memory network, have the vanishing gradient problem, and this optimization is performed by the stochastic gradient descent. Next is the stack autoencoders. If we look into this stack autoencoders, then we can see that there is a input layer, there is a small nodes, that is a small number of nodes present in the hidden layer, and there are certain number of nodes present in the output layer. So this refers to a artificial neural network to learn the coding by encoding a set of data. So encoded data conveys the compressed representation of the data and perform the data compression. So this part is perform the work of this encoding, and this performs the part of decoding. So perform the data compression. So autoencoder contains one input layer, a smaller hidden layer that is encoded the input data, and the output data that is nothing but performs the work of the reconstruction of the input layer. So this is perform the similar action to that of the principal component analysis. Basically, in case of a principal component analysis, we are compressing or we are calculating the principal component to compress the data. Next, the another category of deep neural network model that is called DBMs, that is deep Boltzmann machine. If you look into this architecture, we can see that there are some visible nodes are present, there are some hidden nodes are present. And if you look to the visible nodes, all the visible nodes are interconnected with each other. So that means this V1 is connected to V2, V1 is connected to V3, and V1 connected to V4. Similarly, the other nodes of this visible layer also connected to the other nodes. Similar way, the hidden layer that is H1 and H2, all nodes of H1 is connected to all other nodes of the hidden layer. Similarly, these visible nodes are also connected to the hidden nodes. And hidden nodes are also connected, or in other way, I can say the hidden nodes are connected to all the visible nodes. So this deep Boltzmann machine network of a binary stochastic unit with an energy defined for the network. And there are two types of Boltzmann machines. The basic Boltzmann machine, that is in this case the learning is very ineffective. So in order to overcome this type of difficulty, people are using restricted Boltzmann machine, which doesn't permit the connections among the units of the same layer. So now here is the diagram which shows about the Boltzmann machine architecture as well as the restricted Boltzmann machine architecture. This Boltzmann machine architectures, the nodes of the visible layer are connected to the nodes of the hidden layer. But in case of restricted Boltzmann machine architectures, the interconnection between the visible layer nodes are not present. That means V1 is not connected to V2, or V1 is not connected to V3, or V1 is not connected to V4. Other way also is present in case of a hidden layer. So that means there is no interconnection between the nodes of the same layer. That is, and H1 is not connected to H3, H1 is not connected to H2, like that. So this type of architecture is called restricted Boltzmann machine architecture. This restricted Boltzmann machine architecture is very effective because the output of one restricted Boltzmann machine architecture is given to the input of another restricted Boltzmann, or the input of another restricted Boltzmann machine architecture. So this gives rise to a deep Boltzmann machine architecture. What is this deep Boltzmann machine architecture? After training one RBM, the activities of the hidden units can be considered as a data for the training a higher level of restricted Boltzmann machines. So this method is called the stacking RBM. That means the output of one restricted Boltzmann machine is given to the input of the other. This permits the training of many layers of hidden units in an efficient manner. So the restricted Boltzmann machine stack is known as the DBMs, that is known as deep belief networks. Next is called the deep reinforcement learning. So this deep reinforcement learning combines the strength of both supervised as well as unsupervised learning methods. Sparse and time-delayed levels, referred to as the rewards, are used based on which the agent has to learn how to behave in a given environment. As already I have discussed, in case of reinforcement learning, there is one agent is present, there is an environment is present, there is a feedback from the environment to the agent. And based on this feedback, the agent has to perform a task in such a manner that the reward is get maximized. That means it enables an agent to learn by interacting with the environment. That means always there is a input from the environment to the agent, and the agent has to perform a task to build upon its experience so that it is maximized. It's a long-term reward. And example is Q learning. And what is this Q learning? This is a recently developed deep Q networks, and which is patented by Google. So emerged to represent the Q function of the Q learning with a deep neural network architectures. So this is improved deep Q networks are double Q learning, prioritized experience replay, dueling network architectures. So this is the Q value 1, Q value 2, and Q value up to n, and the network, and these are the different states. So if we'll compare this machine learning concept with this deep learning concept, then we can see that in case of machine learning concept, we have to extract the features, and these features have been used by the classifier to classify whether what kind of object it is. But in case of deep learning, we need not to do the classification, not to do the extraction of the features. The feature extraction is possible by the help of the neural network itself. As in case of deep learning, large number of layers are present, and as already I told, the first layer can able to extract the basic features, or we can able to extract those features, that is in case of pixels, for an image, and whereas the higher layers can able to extract the coarse features. So this deep learning attempt to learn multiple levels of representation by using a hierarchy of multiple layers. If one provides the system tons of information, it begins to understand and respond in a useful way. So that means in machine learning, there is a feature extraction block is present, but in case of deep learning, there is no feature extraction is present. It can be performed by the help of this deep learning or deep neural network concept. So if we look into this deep learning versus this traditional machine learning approaches, this deep learning automatically learns the best features and very flexible, universal learnable framework for representing the world, visual and linguistic information, and can learn both unsupervised and supervised, utilize large amount of training data. Handcrafted features are often overspecified, incomplete, and take a long time to design and validate. So what is this handcrafted features? So this is manually labeled by humans, derived variables or covariate features. Features refer to the properties derived using various algorithms using the information present in the image itself. This is used in traditional machine learning approaches for object recognition and computer vision, such as SVM. One of the example of two simple features that can be extracted from the images that are known as the edges or the corners. A basic edge detector algorithm works by finding the areas where the image intensity suddenly changes. So if we look into the achievements of this deep learning, this can able to achieve near human level image classification, near human level speech recognition, handwriting transcription, autonomous driving, art targeting as used by Google, Baidu, as well as Bing, improved machine translations, text-to-speech conversions, digital assistants such as Google, Alexa, or Amazon, etc. So this deep learning convolution neural network uses this artificial neural network to flourish for the unstructured data, especially for in case of images, text, audio, as well as speech. CNN work best for the unstructured data. Core element of the CNN is nothing but the convolutions, and the CNNs are the simple neural network that use convolution instead of a matrix multiplications. So the convolution output reveal more information about the original signal. A deep convolutional neural network, that is DCNN, consists of many neural network layers. So here we'll talk about the different components of the CNN. We already discussed that the CNN is nothing but the convolutional neural network, and the main component is nothing but the convolution. So it consists of an input layer that which holds the pixel intensity of the image in the form of m cross n cross 3 for this RGB color image. There is a convolutional layer. It takes the image from the preceding layer and convolve with the kernel to produce a feature map. That means the output feature map depends upon the filters. Activation function, that is the ReLU activation function. What is the importance of this ReLU activation function? This output dimension is same as the input and adds nonlinearity into the network that provides a non-saturating gradient for the positive net inputs. Pooling layer, this downsample the 2D activation maps along the height as well as the width, and the fully connected layers, each neuron in this connected to all the neurons in the previous layers. So in case of CNN, we'll talk about this input layer, convolutional layer, ReLU activation functions, pooling layer, as well as fully connected. And we try to see what are the importance of this each layer, why we are going for these different layers, as well as how many layers we can able to use in case of a convolution to get the desired performances. So here the represented in the form of a figure, that is the components of the CNN. I have taken the Mona Lisa image, which is nothing but a color image, consists of 3 channels, red, green, and blue. And we are performing this convolution by the help of different kernels, and we can get the convolution output. Then we are using ReLU activation functions, and we are getting the output. And then we are performing the pooling layer. And why this pooling is very, very important in case of a CNN, and what advantages it is giving, that also we'll discuss. Then we are getting a dense connection and fully connected layer, and this output which is perform the work of these classifications. So we'll start this components of the CNN discussion after this launch break. If anybody has any questions, I can I'll be happy to answer these questions. And these components of the CNN, we can talk around after the lunch break, around 2 o'clock. Let me see any questions are there in the chat box. Okay, no questions are there. If you have any questions, you just keep ready. We'll have a discussion after this class. So at 2 o'clock, again, we'll meet and we'll discuss about the components, and we'll talk about that review of the blockchain based on deep learning frameworks. So I'll stop it here. We'll meet at 2 o'clock.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you, sir.